All right, so I wanted to make another video. It shows you kind of why this is working and what exactly is happening. As you see how this is just vibrating. So this, um, let's see, how do I describe this? Let's take this and let's slow it down and get rid of the damping, right? And well, we'll slow everything down, right? Whoa, whoa. Okay, give it some room. And we're going to slow everything down and give it lots of room. Huh. All right. You know what? Let's get rid of this one for right now. And let's get rid of this one. Let's start over from scratch. Kind of make this thing work a little bit different. Let's see if we can't figure this thing out on the fly. Okay, I'm gonna grab this one. Let's stop it. Okay, so we want to get both of these two going in the same direction at the same time. So swingy, swingy, swingy. Right? These two. And as you look, when it does that, this slides a little bit, right? And what we're trying to do here is just make this kick a little bit more. So we want this to be slightly lighter, right? You see how this swingy is more? Okay, you're actually getting almost two swings for one of these, right? Also, the center of gravity on this thing is completely different now, right? So now let's try taking a big long spring and attaching it to there. Okay, and let's see what happens. Okay, so we're just getting some oscillation. No, no, now we're moving. Okay, good. All right, so pause. So now we want to take this down to here, and boom. Okay, so now we want to tighten this up, crank it down, and make it tighter. No damping. Well, you know, let's see what damping does. No damping, damping. Okay, the more damping, the better. Okay, that's good. And the stronger, better. Okay, good. Target length shorter. Oh, much better. Okay, good. So there's that one. Now, how fast are we going? We're going at 10. Let's slow it down to 1. Okay, and now let's go to tighter and shorter. Oh. Okay, so what is this thing doing? It's basically just falling over. These things are vibrating. You can see how they're vibrating up and down, right? Because of these springs, right? And this thing is basically trying to fall over. You see how it's literally falling over. Um, it's not. It's just it's constantly falling over. That's the problem. So without let's see, it's just because of this asymmetrical force. So it's literally just laying over on its side. So let's see, let's crank this down, make that nice and tight. Drop this. See if we can't get this thing to really get moving. Now, obviously, in the real world, this would just break. But, you know, because it's a computer. Oh, no, I do. Because it's a computer. Now, let's see if we can't pull this whole thing a little bit closer to it. tighter and shorter. Well, you get the idea. Goodbye. So yeah, it's just shake, rattling, and rolling. Um, I mean, it's literally two separate oscillators um, fighting each other. So this one is sending an impulse to that one, and this one's it's just going back and forth. So it's not, they're just falling all over each other. But that's rippling out through this frame, and it's causing it to vibrate, and that's why you can see there's a little gap on the back here, and there's no gap on the front. It's because this thing is literally falling over itself. So if I hit pause, and if I put another heavy weight down in here, right, you can see it's vibrating up underneath of this, right? That's why it's doing. It's not like this is, you know, it's literally jumping up and down. You can see it, right? It's harder to see up underneath here, but this is just vibration. It's not magic. It's just vibration. It's just this is vibrating, and you can't really ever stop it from vibrating. So this is going to do it perpetually until it runs into something and stops. Which I mean, sure. I guess if it can't pulverize and destroy anything in its path, that's probably not perpetual motion. But it clearly is going to keep going as long as it wants. And yes, I understand it's a computer simulation. But it's a computer simulation that's built off of the Lagrangian math. So it's literally taking, boop, it looks at all these components, and it says, okay, I'm going to figure out this one. I'm going to figure out this one at this particular point in time, and this one's going to be pulled that way, and this one's going to be pulled this way, and this one's currently moving here. And it doesn't matter if I stop this whole thing. I'm going to stop the velocities, and then hit start. It doesn't matter. It's because the force is still in here. It's because the compression. I'm not deleting the compression out of the springs, right? And once one pulls one way, this one pulls the other way. So it's physics, baby.